Hello and welcome to the rest of Lesson 4.2 about angle relationships in triangles. We did start most of Lesson 4.2 at the beginning of class. We're going to cover kind of just the rest of those notes pages on 4.2. In 4.1 we did learn how to classify triangles by their side or angle measures, and now we are applying the triangle angle sum theorem, which again just means all the angles in a triangle add up to 180 degrees in measure. So let's go ahead and get started right away on these next examples. So I want you guys to find the measure of each of these numbered angles, 2, 1, and 3. Go ahead, and if you need some time to go ahead and complete this, pause the video. Otherwise, you should be ready to go ahead and tell me what those answers are. Alright, let's take a look at the measure of angle 1. You'll notice angle 1 forms a linear pair with this 57 degree angle, so if I do 180 minus 57, I do get 23 degrees. So the measure of angle 1 is 23 degrees. Measure of angle 2, if I take these measurements, 57 plus 71, and add them up and take it away from 180, I get 52 degrees. So the measure of angle 2 is 52 degrees. And then for the measure of angle 3, again, we can add up 23 and 28 and take that away from 180, and we do in fact get the measure of angle 3. But you'll notice that 57 is an exterior angle of JLK, and so the sum of these other two angles, you might remember, should be the same as that 57. So I could just take 57 and subtract 28 and get that the measure of angle 3 is 29. Alright, let's go ahead and take a look at the next part, example 1b. We're looking for angles 4, 5, 6, 7, 8, and 9. So this seems a little bit tricky, but we do have a lot of information to help us get started there. Looking for all these angle measures, but it's going to be a little bit easier since we know that 8 and 9 are congruent angles. We know they're going to be the same. 5 and 7 are congruent angles, so they'll be the same. So really we don't have as much to find. Once you pause the video, give yourself enough time to find these individual measures, remembering that all three angles of a triangle add up to 180 degrees. Alright, if you need more time, pause again, but if you are ready, these are the answers we should get. Alright, I'm actually going to start by finding the measure of angle 7, because I've got two angles of this triangle. So if I add these up and take them away from 180, I get 57 degrees for angle 7. So angle 5 has to be the same because they're vertical angles. That allows me to find the measure of angle 4, because if I add 57 and 67 and take that away from 180, I do get 56 for the measure of angle 4. Then I can find the measure of angle 6 just by taking 57 alone away from 180, because it's a linear pair with angle 7. Now to find the measures of angles 8 and 9, I'm going to take 180 and subtract 123 and realize that these two angles should add up to 57 degrees, because if I add all three, they add up to 180, and so the two of them should add up to 57 when I take away the 123 from 57, and they're both the same, so I could just call each of them x. So really each one is going to be half of 57, which gives us that they're each 28.5 degrees. Alright, let's go ahead and take a look at another idea that we've kind of been talking about already, and that's the idea of an exterior angle. Angle 4 is an exterior angle. Its remote interior angles then are going to be these angles 1 and 3. The remote interior angles, remote meaning away from, okay, they're there. And what we notice, you might remember from our work with those triangles that we tore apart in class, is that the two remote interior angles are going to have a sum that is equal to that exterior angle. And so that is our theorem called the exterior angle theorem. The measure of an exterior angle of a triangle is equal to the sum of the measures of the two remote interior angles. So in this case, angle 1 has a measure equal to the sum of measures of angles A and B. So we're going to use that in these next few problems. Let's take a look at this proof. Now, most of this proof has been done. We're just going to fill in some of the given information. We always want to start with the fact that we are given triangle ABC. All right, and we're going to prove then the exterior angle theorem. So we're going to quickly do this proof before we move on to another problem. So here's what we know. In a triangle, all three angles must add up to 180 degrees. That is the triangle angle sum theorem. All right, but before I go on to the rest of this, notice that this kind of line of logic has to fill in first. Now here's what we do know. Angle 1 and 2 do form a linear pair by definition of a linear pair. And angles 2 and 1 have to be supplementary. And again, that reason's not the best way of saying it. That's just our linear pair theorem. All right. Since they're supplementary, I know their measures have to add up to 180. That is just the definition of supplementary angles. So since these two measures add up to 180, and I know that all three of these add up to 180, A plus B plus 2 has to be the same as 2 plus 1 by substitution. We're substituting this in for 180 degrees. And since that is true, notice there's a measure of angle 2 on both sides. I could just subtract that from both sides and get the measure of angle A plus measure of angle B equals the measure of angle 1 by the subtraction property of equality. So there's our proof of the exterior angle theorem. If I have an exterior angle, it is equal to the sum of the remote interior angles. So let's find the measure of angle B in the next example. We are given angle A is 15 degrees, angle B is 2x plus 3, and 5x minus 60 is the exterior angle BCD. From that theorem we just looked at, the measure of angle BCD, which is an exterior angle, has to be equal to the sum of the remote interior angles, measure of angle A plus measure of angle B. Then we're just going to substitute the values we have in this diagram. This is replaced with 5x minus 60. Measure of angle A, we know for a fact, is 15 degrees, and then measure of angle B is 2x plus 3. So what we want to do is solve this equation for x and then plug it back in to find the measure of angle B. I'm going to let you guys pause the video and take time to solve that equation. Alright, this is what we should get for the value of x. X equals 26. So I take 26 and plug it back in for the measure of angle B. That's 2 times 26 plus 3. So the measure of angle B equals 52 plus 3, which is 55 degrees. All right, let's try part B. We have right triangle ABC, and we have this exterior angle ACD as 6z minus 9, and the interior angle A is 2z plus 1, and you do know that the right angle has to be 90 degrees. And so to find the measure of ACD, we're going to set up an equation. I want you to remember the measure of the exterior angle, ACD, has to equal the sum of these remote interior angles. So we know 6z minus 9 has to be 2z plus 1 plus 90. So once again, solve that equation, find the value of z, and then plug it back in to find the measure of angle ACD. Alright, if you need more time, pause the video. When you're ready to go, this is what we should get. Z should be 20.5, and when we plug it back in, the measure of ACD should be 114 degrees. Alright, let's take a look at a real-world example. Let's say that we're taking a look at this triangular pose here, where the legs form the sides of a triangle, and the third side would be the ground. We have this diagram. This angle's x degrees, this angle's 50 degrees, and the exterior angle here is 2x minus 15. And so we should be able to write an equation that looks like this. 2x minus 15 equals the remote interior angles sum, x plus 50. All right, to find the measure of angle JKL, we need to find the value of x. So go ahead and find the value of x, plug it back in, and find the measure of angle JKL. We should get x equals 65, and when you plug that back in here, 2 times 65 minus 15 is 115 degrees. All right, just a couple more things to discuss here in the notes. We have the idea of a corollary introduced in this lesson. A corollary is a theorem that can be proven directly from another theorem. And so our triangle angle sum theorem gives us these two corollaries. One, the acute angles of a triangle are complementary, so these non-right angles have to add up to the other 90 degrees of the full 180. And we also know that you can have at most one obtuse or right angle in a triangle. And those are kind of ideas we've already talked about. But those both come from the triangle angle sum theorem. So let's take a look at the two-column proof for that corollary 4.1, which states that the acute angles of a right triangle are complementary. So we are given right triangle ABC. We want to prove that A and B are in fact complementary. So we're going to start off with the given information that we have right triangle, and you can use that symbol instead of writing the word triangle, ABC. That is given. Then I've already given you parts of the proof to go from here. We know that A, B, and C should have measures that add up to 180. And again, this corollary comes from the triangle angle sum theorem, so we can start with that. And then we also know the measure of angle C is 90 just by definition of a right triangle. Now, that means we can take the measure of angle A plus measure of angle B, and instead of adding the measure of angle C written this way, we can add in that actual value of 90. That's just substitution. All right, so we've got this equation. We want to prove that A and B are complementary from this equation. Well, it would be very easy just to subtract 90 from both sides and get the measure of angle A plus measure of angle B does in fact equal 90. That's just by the subtraction property of equality. But then if their measures add up to 90, we know that they're complementary by definition. So we can go ahead and state the final part of our proof, that A and B are complementary. Sorry, let me write that M a little bit better. And that's just by definition of complementary angles. All right, let's take a look at our last example. So we've got a diagram here. We're going to kind of put all of our information together and try and find the missing angle measures, 1, 2, 3, and 4. And so I want you to kind of look at this, and you'll need to pause the video here, but try and find ways to find the angle measures given based on the corollaries and theorems we've talked about so far. All right, this is what we should get. Since angle 1 is an acute angle of a right triangle, I know that it's the complement of this 52-degree angle. So all I have to do is 90 minus 52, and I get the measure of angle 1 is 38 degrees. And since measure of angle 2, that's an acute angle in another right triangle, it's going to be the complement of the other acute angle, which in this case is 38 degrees. So the measure of angle 2 is the complement of 38, which we already know is 52. And then I've got angles 3 and 4. You'll notice that angle 3 is part of a right angle with angle 2. So they have to be complementary also. So angle 3 is the complement of angle 2. The complement of 52 is back to 38. And then angle 4 is the other acute angle in yet another right triangle. So angle 4 is the complement of angle 3. Complement of 38 again is back to 52 degrees. So all of these angles either end up being 38 degrees or 52 degrees because they are complements of one another. All right, this wraps up our lesson notes on lesson 2 over angle measures in right triangles, or angle relationships in right triangles, or sorry, in triangles in general, with specific to right triangles here at the end. And so we should be able to understand this a little bit better, and we'll start the book assignment in class.